Okay, so I've got my Yamaha P-2200 here, but I'm going to try and replace the output transistors on. I got this thing cheaply because it didn't work when I got it. Well, one channel was very distorted, and upon fixing the biasing circuit in it, I discovered that some other repair tech had put the wrong output transistors in it. This thing runs on I think it's a 180 volt power supply, and the damn output transistors can only take, I think it's 140 volts, absolute maximum. So if I were to play it loud enough, it would blow up probably long before it reached its maximum output voltage. I have new output transistors. They are MJ15023s and MJ15022s. And in here we've got the old ones, the wrong ones. They are, I think they're ON2 actually. Hang on, just let me, what have I got? No, they're not OJ, they are MOSPEC MJ15016s and probably MJ15017s then on the other side. I was actually wrong about the other transistors. They are Motorola brand and different batches, all of them. MJ15015s. And if we take a look at the other channel, which is should be completely original transistors at least, we've got 2SA909s and whatever their complements are. And I just looked up the datasheet for them, and they're not the 15015s, replacements for the bloody 2N3055. They're rated for 120 volts collected to emitter voltage, absolute maximum. And if we have a look at the datasheet for the 2SA909, we've got a maximum collected, maximum collected to emitter voltage of 200 volts. So yeah, these are not the right transistors. Okay, I've now got the other channel hooked up to the meter here, the one with the wrong output transistors. It's putting out pretty much 1 watt of power, a bit more, just as the other channel was, so let's see how much distortion we've got. Seems to be more than 0.01. We've got 0.024 or thereabouts. So that's almost 3 times as much as the good channel. So I guess we're going to find out if it's just these transistors that are acting up, or if there's some more work that needs to be done on this channel. The new power transistors are installed for both voltage rails, and we're hooked up to my power meter here. So let's see if it still powers on, or if it's gonna blow. That does look fine. We're drawing 34 watts. That's about the same as before. I'm gonna check for any DC offset before I hook my load into it. 90 millivolts. Well, that's not dangerous or anything, but it's fairly high. Wonder what the other channel's got. 3.1. I don't think you can actually adjust the DC offset on this thing, so it has to be some mismatched pair down in here somewhere. Guess I'm gonna have to take the whole board out before I'm done with it. Before I take it all apart, let's see how much power this channel can push now that it's actually got transistors that can handle the voltage. Okay, now we're pushing about 270 watts into my 8-ohm load. I'm gonna have a feel around to see if it... Ouch! Yeah. Tip from the coach. This is ground. And the transistors are either your positive or your negative supply rail, so you're not gonna wanna touch your transistors while you're touching your heatsink, because that hurts quite a lot. This is really not producing a whole lot of heat given the amount of power it's pushing. These humongous heatsinks sure do their job. Okay, I've got the amplifier module out here, standing on top of the amp. It's really nice and service friendly, and it's actually not as bad as I remember. The only transistors I can spot having been replaced are these guys here that make up a protection circuit in case a power transistor blows, and this guy down here in the biasing circuit, and the drive transistors, these guys. And none of those should really matter when it comes to DC offset and distortion, unless the drive transistors are really poorly matched. But all the small signal stuff is in this area here, and it's all original. However, I've got my Aten 858D hot air gun here, and watch this. You can actually run the amplifier with a module on top like that. Don't believe me? We've still got our DC offset here at the speaker terminal. So I'm gonna try and, if you bear with my loud ass fan here, I'm gonna try warming around a bit and see if we can affect the DC offset and find out which transistors to replace. I think what matters most is the current mirror here, because if I warm one of those, it goes right up. And since these current mirrors, they depend on the actual gain, absolute gain of the transistors to be roughly the same in order to work properly and not cause a DC offset, I think I'm just gonna go ahead and replace those guys. Okay, I've got my new transistors installed here. Put a bit of thermal goop on them. Not the normal heatsink compound, but it's more of a glue-like stuff. The stuff you usually find on power supplies, gobbed all over the caps. So hopefully we should have a bit better thermal connection. They shouldn't drift in gain so much, and it should generally be better. Alright, let's see what happens. Well, this does look better. Yeah, we're on the 200 millivolt range now. This is fantastic. The DC offset is gone completely. We are making a... oh dear, we're just not making a connection. Oh, what a shame, what a shame. 23.5 millivolts. It actually got worse. Check this out. I just replaced one of the pre-driver transistors, and I've got my meter here set to 0.01% distortion full scale, and the amplifier is rated for 0.01 exactly or less at 200 watts RMS, and the dial's just jumping at 0.011 or so, 0.012. It's pushing about 200 watts now, and it's going just slowly up as the amplifier is warming up. But this is like half as much distortion as it had before I replaced this guy here. It's just a random transistor from the junk box. And turn it down now. It doesn't have the best cooling when it's sitting like this. Although it hardly even gets hot. But yeah, this is the guy that used to be there. And it has seen better days. It's run so damn hot that I actually made a mark in the transistor when I had to rip it off of the heatsink, because the old thermal paste had just glued it stuck there. I just replaced 2 diodes and 1 transistor, and the thing is bloody taunting me. But you see that? That meter's hooked up to the output, as it always been. And the damn thing isn't even on, yet there's a bloody DC offset on the output of 24 millivolts. I mean, it's not even plugged in. Come on! Okay, so I'm hooked up to my distortion meter here. We're putting out a very low signal, about 0.1 of a watt. We can see the distortion of the meter there, on the scope there. And I've got a big ass fan blowing on my load here, and that's why it's so loud. So, because the load is essentially an 80 watt load if I wouldn't have a heatsink on it. And the heatsink can handle perhaps, yeah, a bit over 100 watts. So it needs the fan to handle 200 watts continuously. So let's get some power going here. Input range 10 volts to start with. Yeah. And I've got my meter here hooked up to the output of the amplifier, so we can see the voltage on it as well. Let's get some about 10 watts. There we go. 9 volts. And we have 0.004% THD plus N. To make sure the load is connected, we're drawing 116 watts. So this is all fine and dandy. This is about the same performance as the other channel actually. I'm quite surprised. I was not expecting that. We can see the noise waveform. It's mostly just noise, not a whole lot of harmonic distortion. Let's crank this a bit. Let's try 100 watts per channel. And if we look at my chart here, 100 watts into 8 ohms should be 28 volts. Let's do that. There we go. And we have, let's make sure, yes sir, we output on distortion. We have 0.0026% distortion at 100 watts. It's just pushing one channel though. So we should expect rather good results if the channel is working. This is considerably better than before. I have never seen this channel perform this well. And I haven't done distortion test since I replaced these 2 diodes here and a couple of transistors here in the power limiting circuit. So perhaps those were a big part of the problem with this amplifier. As you can see, the meter on the front, which should be rather well calibrated, also agrees where it's 100 watts. However, we are rated for 200 watts at 0.01% distortion or below, so let's do that. 200 watts into 8 ohms, that should be 40 volts. So we need to go to the 100 volt range on the distortion meter. We're going to have to adjust here because we can only take 2 decibel steps on the volume control on the amplifier. Oh, I think I just blew a fuse in the load. No, I did not. Something down here made a noise. I have no idea what that was. Apparently nothing too dangerous. You do get a bit jumpy when you deal with stuff this powerful. I mean, if a transistor head decided to blow, it would produce, well, it could produce quite the flame. So let's get that power going again. .44 volts. Let's turn that down. We are clipping now. There we go. Oh, that is not very beautiful. That's a distortion waveform. That actually looks rather terrible. Oh, we must have been clipping in some stage. Let's see, we're at 31.8 volts, that's about a bit over 100 watts. Let's see how high we can go before we get over the 0.01 limit. There we go. Right around there. 38.4 volts. That's... yeah, we're definitely right on the verge of clipping here. Something is. 38.4, that is... yeah. About 150 volts. No, wait, 38.4. About 180. Producing a lot of heat. Alright, so I went to town today and got myself a few parts for the amplifier. So now I've replaced these power limiting transistors to the right ones. Well, proper replacements anyhow. BC327s. The old ones had way too little gain, so they didn't do the job. And I've also replaced this capacitor here, which was supposed to be a 0.47 microfarad one, but I didn't have any in stock at the moment when I recapped it, so I put a 2.2 mic electrolytic there instead, with a 0.47 mic film cap. And I've also replaced the bias potentiometer to a somewhat more suitable unit. The old one was just something I scavenged out of an old power supply to see if the thing would even run. So, and it was way too small. Let's see if we can find it here. Here we go. And I'm not sure if it can actually handle the power that's being dissipated there. The original is a very big wire wound thing that you of course can't get your hands on. But I've got it hooked up. And let's see if it powers up or blows up. Since I replaced the bias potentiometer, I'm gonna have to set the bias on it. Here we go. Looks good. Drawing 32 watts. Oh, yeah, we don't have any bias. Gonna let it warm up a bit before I try to set it. Okay, so I've put it back together now, temporarily, with a couple of screws, and let it warm up a bit, playing a 5-wave sine, 5 watt sine wave into my load, and let it warm up and stabilize for a while. I'm gonna do a noise floor test on both channels, because I think I'm going to let this channel be for a while, because there isn't much more I can do with it aside from replacing the driver transistors, which are on back order from, I believe it's Mauser, and they're gonna come sometime, I hope, and do a full recap on it, for which I need to go and get some components from town, and don't go to town very often. And I'm gonna do some work on this channel, since it seemed as if the repairs I've done to this channel has improved its noise floor quite a bit. And I'm very picky when it comes to noise floors. That's why I use my Luxman amplifier here in my main stereo, because it has a very low noise floor according to this thing here. So let's see what we've got on the Yamaha. Right now the fixed channel is about minus 77-78 dBV. So if we move the meter to the original channel, well, there we go. This channel has pretty much the same noise floor. Minus 77, minus 78. Yeah. Well, I suppose there's not much else to do then. This unit's gonna have to take a break until I can get my hands on some more components. Alright, I think I'm gonna split this video into two parts right about here. But I think it would be a shame not to hear this puppy sing before I do. I've got it hooked up to my test speakers here. Got some Creative Commons licensed music. Let's see what it does. These are 4-ohm speakers, by the way, so there's about twice as much power as the meter says going into them. Good job with the muting circuit, because there isn't really much of a pop at all. Yes, this is fantastic. Even though it isn't quite up to spec, I'm very happy with the progress I've made. Yeah, cheerio.